Okay, so here we go. Substitution. Remember what we do is when we take a look at the problem, we look at this guy and we say to ourselves, if I take x to the minus 1, if I square it, is it x to the minus 2? And the answer ends up being yes, because 2 times negative 1 is negative 2. This problem can also be worked in more than one way, because if I were to look at this is 20, x to the minus 2 plus 9, x to the minus 1 plus 1 equals 0. I can make all the exponents positive. 20 is positive, and that would be x squared. 9 is positive, he stays in the numerator, but x moves to the denominator, plus 1 equals 0. Now it's a rational equation, and then you clear the equation by multiplying through by x squared. Some of them can be worked in more than one way. This would be my plan B. Substitution makes it easier, however. So that says I'm going to let u be equal to x to the minus 1. So if I square x to the minus 1, I should end up with x to the minus 2. So my problem comes out to be 20 u squared plus 9u plus 1 equals 0. And this does factor. I had to think about it a little bit today. As to 4u and 5u, both 1s, everybody's plus. So that u is negative 1/4 and u is negative 1/5. This is going to be a little different than your pre-homework in a sense, because you're not going to have the fractions to start out with. But I know that if u is negative 1/4, x to the negative 1, that's what u is negative 1/4. X to the negative 1 is negative 1/5. Now, what's that going to mean to me? Well, if x to the negative 1 is 1 over x, it's negative 1 over 4. X to the negative 1 is 1 over x, it's equal to negative 1 over 5. So, but I don't want a 1 over x, I want x. Now remember, yesterday we flipped these guys. I think in this class we did that. I don't remember whether or not I did or not. Maybe I didn't. Probably didn't. Yeah, it must have been the other class. But here, what you can do is, because it's a rational equation, just multiply both sides by the common denominator, which is 4x. The x's reduce out. 4 times 1 is 4. Equals the 4's reduce out, minus x. I have the opposite of x is equal to 4, or x is equal to minus 4. Here I have 1 over x equals negative 1/5. Now, the other thing that you can do is this. From arithmetic, if I know that 1/2 is equal to 3 over 6, that's true. If I flip one side, I have to flip the other side. That's also true. So whatever I do to one side of an equation, I do to the other side of the equation, it's true as long as I do the same thing. So that means that I could say 1 over x, well, this would be x over 1. And 1 over 5, this would be negative 5 over 1. So that x is negative 5. Here I just flipped both sides. So I flip both sides. So either way, this is much more familiar to us because that's how we're used to doing it. And this one is something new. But that's true only if I have a single fraction equaling a single fraction. Now,